In problem number 3, we're going to explore, again, factoring, but now our first term, our leading coefficient, is not equal to 1. So we have to add a little bit more to this process. So instead of just looking at the last term and thinking about factors of the last term, now we're looking at factors of the number 2 times -3 that has to add up to our middle term 1. So now we're looking at A times C, so that's 2 times -3 is -6, and we need factors of that add up to 1. So our factors, of course, are 2 times -3, but we can also think about the opposite of that, -2 times +3. And of course, like -6 times 1 and -1 times 6. But again, we have a situation where we need to add up to a positive number. And if I check to see which one of these adds up to +1, it's going to be the second one, -2 times 3. So now let's use the box method of factoring. You could also use trial and error. That's totally acceptable, but I always like to give you some sort of tool. So we're going to put the first term in the first box, 2x squared, -3 in the last box. And now we're going to use our coefficients that we found, -2x and +3x. Just notice, if we were combining like terms, we'd add these two terms together, and guess what? They would equal 1x. So now we need to factor out our greatest common factors from each row and column. So let's start with column 1. My greatest common factor is x. For the second column, the only thing that I notice is that both of these have a negative sign. So I'm going to say that the greatest common factor is -1. The top row, 2x is the greatest common factor. And in the bottom row, 3 is the greatest common factor. Notice the signs are different, so I'm assuming that this is positive. Now we're going to check. So 2x times x equals 2x squared. 2x times -1 is -2x. 3 times x, +3x. And 3 times -1 is -3. So that works, which means our our binomial factors of this equation is 2x plus 3 and x minus 1.